All right, welcome to Unit 7, so our last unit of the year. And so we're dealing with some new functions. We're dealing with exponential growth and decay to start with. And so there's some kind of interesting things about this. We're going to kind of come down here and we're going to talk about like our family of functions. And this is going to look a little bit differently or a little bit different than anything we've seen before. And so our family would be f of x is equal to b raised to the power of x. And I want to talk about this b a little bit. So b is the base. And so notice that the exponent, the variable, is an exponent, which we have not seen that before. Normally, what we've seen is we have like, let's not try that one. We have like x squared or x to the 3/2 or y to the 5th or something. But now we have that exponent, so these are called exponential functions. We have that exponent as that is a variable. And so this base is a number. And so the base, now there's kind of two conditions here that we'll talk about here in a second. The base is greater than 0, but there's kind of some different things happening. If that base is greater than 0, but less than 1, we're going to talk about what's happening here. And if the base is greater than 1, there's something else happening. And so we'll come up and talk about that when we do our growth and decay up at the top. And so our equation, you guys should be able to know what that is. Y equals b to the x. And again, base is a number. Our domain for this is pretty easy. Negative infinity to infinity. The range, those y values, for the parent function would be 0 to infinity. And so now this does have an asymptote. The asymptote, it actually has a horizontal asymptote, right? And that asymptote on the parent function would be y equals 0. Now this does have an intercept, and we'll come down and graph those, and you can see where those are. But this intercept with no transformations is 0, 1. And characteristics, no vertical asymptote, and the y values are going to change rapidly. So exponential growth is fast. It's, I think, the second fastest type of growth that we can get. So let's come up here, talk about a couple things. So our essential question, how are exponential transformations similar or different from other function transformations? Well, surprise, surprise, they're exactly the same as all the other transformations, but our equation, our transformation equation, is going to be a little bit different. So exponential growth, and we'll talk more about this later, but that is going to be this rapid growth. And so this occurs when the base, right, is when, let's write it like this, when the base is greater than 1, we're going to get exponential growth. And this is going to be like super fast growth, as we'll see. We'll do some examples and you'll see. That looks kind of weird. Let's move that 1 over a little bit further. And exponential decay, this is going to occur when our base, so our base is in between 0 and 1. And so notice for exponential growth, our base is strictly greater than 1. And for decay, we are strictly greater than 0 and strictly less than 1. So if our base is 1, and think about that, like think kind of about what that means. If our base was 1 and we had 1 raised to the x can be any number. I mean, this could be 1 to the 0, which is going to be 1. It could be 1 to the 10, which is going to be 1. So if our base is a 1, it's not exponential growth. It's some other type of thing. And it's not decay either. It's something kind of interesting going on. I think you guys are all pretty sharp with horizontal asymptotes. We have a pretty good idea of what that means, hopefully, from our last unit. And so horizontal asymptotes is just a horizontal line that the function approaches. And so that's it. And now we're going to come down and we're going to graph this guy. So we're going to take something, because we can't put b in our calculator. That's kind of strange. And so like our parent function is that b, and I'll accept either that b to the x or f of x equals 2 to the x. And this is kind of like our standard parent function is 2 to the x. So what's going to happen here is we're going to find x values when we raise 2 to the x. And so that's going to give us some values. I will help you put this in your calculator. So let's open up our calculator. And so first off, let me change these windows a little bit and get a little adjusted here. Okay, so we want to put 2 to the x in the calculator. So that's just our, I'm going to go to y equals, and I'm going to come down to y1 just so it matches what you're seeing on your calculator. We're going to input a 2. We need to use this cursor, or the caret, to get that exponent up, and then we're just going to put x in. And let's go, while we're here, let's go ahead and take a look at the graph. So there's our graph, and I can change my window quite a bit easier than you guys can. And so that's what our graph looks like. We can see we have a horizontal asymptote. It appears we have that horizontal asymptote at y equals 0, which is essentially the x-axis, right? And then it looks like here's what we're talking about for this fast growth, right? Look how fast this thing grows. So here let's see, let's change this window a little bit. Okay, almost. Okay, so our window is 1 to 1, right? Not our window, but our scale is 1 to 1. We can see that when x is 1, y is 1. And then, so when x is 1, oh, that's y. Okay, that's too bad. When x is 1, y is 1. When x is 2, y is 4. When x is 3, we're at 8. When we're at 4, we're at 16, all the way up there. So we can see that this is growing pretty quick. We want to get some y values. And this is going to, at times, be like some of the other things, the graphs we've done, where it's going to be tough to get a graph. And so the things that we're looking for is like y-intercepts, x-intercepts, and that's going to help us get what we need. So let's go to second graph, and we'll pull up that table of values. I'm going to pause. I'm going to copy some values over here. And I do want some negative x values. So I'm going to scroll this way, I guess. And we don't know what those numbers are. They're pretty terrible. We know that's an asymptote. So I'll just start, I guess, at like -2. I'll let you fill the... And I changed my mind. I'm going to start with -3. And so if we didn't have a calculator, we could figure this out using our knowledge of exponents, right? We know that this becomes 2 to the -3, and we don't like those negative exponents. So this is really 1 over 2 cubed, which would be 1 divided by 8. And we can look at -3, and we see on our calculator, right, that is 0.125. So we could figure these out, and I'll let you write the rest of these in, and I'll pause this, and then we'll continue. And I'll let you go ahead and graph it. All right, I filled my table out. We've got it graphed, and we're ready to start working on some problems. When we're graphing these, you have to graph those horizontal asymptotes. And so let's take a look at our transformation equation down here. So again, these transformations are the same as they've been, right? A is a vertical stretch or compression. It's also, right, if A is negative, it's a vertical reflection. And so hopefully you guys, we've been doing this for a while, have that. I want to stress that this B, that B value, is not a transformation. It's a base, and it is a number. And it has to be greater than 0. And so there's going to be some other things that's going to change, right? We talked about growth or decay. If the value is bigger than 1, if B is greater than 1, it's growth. If it's in between 0 and 1, it's decay. So when that graph is getting smaller. Our parent function that we've got, we can still see it in the window over here. Our parent function, that is a growth. And we can look at this graph and see that it's a growth because as our x values are getting larger, our y values are going up. And so think about like this graph has a positive slope. Okay, so let's go. Now, our h is right connected to the x value. And so that is our horizontal translations left to right. And our k value is up or down. And think of that as like our d value if we're finding a vertical asymptote. But this k value, something interesting about this k value is your horizontal asymptote is y equals k. And so that's going to help us to do some graphing kind of later on, right? We can look at whatever whatever we've added or subtracted on the end of that, and that's changing our y values. That's going to give us that horizontal asymptote. So let's take a look at, I don't know, which one do we want to do? I think I would like, let's do example 2, and you guys can do example 1. So let's do 2 together. So I'm going to zoom in a little bit, and we're going to talk about some stuff that we know right off the bat, hopefully. I'm going to change my window here just a little bit. Okay, so here we go. I'm looking at example 2. What do we know? Well, they want to know if it's growth or decay. I look at that base, right, that base. So I know that b is equal to 1/2. The negative doesn't do anything for growth or decay. That's going to be a reflection, a vertical reflection. So base is 1/2. That's less than 1, greater than 0. So this is decay, so our slope is going to be a little bit different. I also know, looking at this guy, that my horizontal asymptote is y equals 3. And we could sketch that in right now if we wanted. 3, and so there's our horizontal asymptote at y equals 3. And now we want to graph this. We don't want to spend tons of time trying to put values in for x and compute this and stuff. So I'm going to change my window a little bit. We're going to go back to y equals. I'm just going to clear that out, and we are going to input this function exactly as we see it. So remember, we talked about this last time a little bit. We're going to use the calculator function, or the fraction feature for this. And so before I input that fraction, I'm going to start with that negative, right? And so I'm just going to type in, don't forget it's a negative, so not a minus. And then you need to open a set of parentheses, super important. And now we're going to input our fraction. So we're going to go alpha, y equals, enter. We get our fraction. I'm going to input 1/2. You're going to have to arrow key over to get out from in there. We're going to put in a second set of parentheses, and now we're going to raise it. I'm going to use the caret. We're going to raise it to the power of x. And so we're still in that exponential, in that exponent spot. We're going to have to arrow key over, get down, and now we're going to enter +3. And so there's our function. Let's take a look at our graph and see what that looks like. So we knew that this was going to be decay, but it really does look like growth, but it's also that reflection, right? So if this wasn't reflected, this would look like exponential decay. It still looks like growth, but notice our horizontal asymptote at y equals 3. We're never going to cross that line at y equals 3. So let's get, and we can look at this graph, and we can see it looks like we have a x-intercept at 2. So let's mark that. I'll do it in red. I'm sorry, I said the x-intercept. I meant y-intercept. But let's get the x-intercept while we're here. It's in between -2 and -1. It looks like it's negative 1.75. So we can mark that guy. I guess is about right there. And so maybe we want 1 or 2 other points over here. It's going to be tough, right? Now we could go to our table of values, second graph, and we could get some coordinate points. We can see there at 0, we're at 2. At 1, excuse me, we're at 2.5. So 1 is 2.5. And then we should probably get some other y values like negative, let's go -3. So 1, 2, 3 is -5. 1, 2, 3, 4, 5. And so we can kind of see what's going on there. So that looks okay. At this point, really, we could just connect it. We just want to be sure we don't cross that horizontal asymptote. So we're going to kind of come up, we're going to follow it, and that's it. There's our graph. So not too terrible. All right, so we need to talk about some transformations, and I'm going to zoom in a little more. I can't really slide this the other way anymore. That's okay. So transformations in order. There is no horizontal transformation. It hasn't been moved left or right, because we're not changing, we're not adding or subtracting anything to that x value. So no horizontal translation. There is a vertical reflection. So there is a vertical reflection. The temptation is to look at this 1/2 and think, oh, that is a horizontal, or sorry, a vertical compression by 1/2. But that's the base. This is not a transformation. The base is not a transformation. So that 1/2 doesn't do anything as far as transformations go. And our final translation is at up 3. And so let's talk about a couple things. We need domain and range. We already found the horizontal asymptote is y equals 3. The domains for these ones is the easy one. It's -infinity to infinity. The range starts with that vertical asymptote, or that horizontal asymptote, so we know that our y value is 3. But look at our graph. Like, we always go with the smallest y value, and we know that we're coming from -infinity. We're going to come from -infinity, and we're going to follow this line, and we're going to butt up right up against that horizontal asymptote of y equals 3. So looking at the range of this, we're going from -infinity to 3, and that's it. So I want you guys to work on example 1, and I'll give you a little bit of help before I turn you loose on that. I'll help you put this in your graphing calculator. And pause this if you're still working on example 2, and then come back and we'll work through this. We'll do some of this together, but not a lot of it. You're going to do the majority of this, example 1. So I'm ready to put it in the graphing calculator so we can get an idea that we can start building our graph. We know a couple of things. Our base is greater than 1, therefore it's growth. We know that we don't have a plus or minus that k value, so our horizontal asymptote has not changed from the parent function. Our horizontal asymptote is going to be y equals 0. You can do the rest of the transformations. Remember, the base is not a transformation. And so now let's put this in a calculator. So we're going to start with that 2. And then you do need to open a set of parentheses. There's more than one way to input this, but the parentheses I really do think work the best. 3, close that. And so now we want to use our caret, and we want to go x plus 1. And just make sure, like some of us, we might have older calculators. If you get that x, it might just kind of bump you down. And so we don't want to do this as like x plus 1, because I've turned that into a vertical translation up or down. So I'm going to back up a little bit. We're going to back up, and we're going to add our plus 1 right there. And so it looks the same. That x plus 1 is all an exponent spot. We can take a look at our graph, and we can see this is definitely growth, right? As my x values increase, as we move from the left to the right, the y values are getting bigger and bigger. And so at that point, I'm going to let you graph the rest of this. So you can pause the video and graph, and you can check your notes in Classroom, and you can do the domain and the range. And I think, like, we'll come back. I'll talk about a couple of these, example 3 and 4. The last page of this is something we've done a lot of times, and I'm not going to fill this out with you. We've already done that a few times. If you want it, it's in Google Classroom. You can fill it out. So pause the video, take a break for a minute, and then we'll come back and we'll do example 3 and example 4, and I think maybe example 5, because those are the types of problems that we're going to see. All right. So let's talk about example 3, and like the easiest thing to get to start off with, and I think like the easiest thing for all of these is the domain, -infinity to +infinity. In fact, let's just fill out example 4 at the same time, -infinity to +infinity. And then let's take a look at probably the next easiest thing to get, or something that I think is pretty easy, is those horizontal asymptotes, right? And so, which is also going to give us our range, right? Those horizontal asymptotes and those range values go hand in hand. So I know that we're adding 10. We have that vertical translation. We moved it up 10, which means my horizontal asymptote is y equals 10. There's no reflection here. And so that means that my range is going to start at that value. It's going to start at 10 and go to infinity because of growth. And you can graph this, put this in your graphing calculator, and take a look at it. The transformations, well, so, and again, let's make that a little bit bigger. That 5 is the base. It is not a transformation. And so the 3, however, is a vertical stretch by 3. And then we have 10, so that's up 10. And the only thing we're missing is it growth or decay? So my base is 5. That has to be a growth. That has to be growth. I'm going to let you do example 4 and check your work in Google Classroom. And we're going to do example 5, and then we're going to be done. So we have an equation. We're going to write the equation for f of x is equal to 2 raised to the power of x. And we're going to do 2 different transformations. And it's asking us for an equation, so we need an f of x, or you need a y equals, but we need some equal signs and some type of like function name, right? Y or f of x. And so like the easiest way, I think, is to just copy this, kind of like we've done before. And so we're going to go left 5 units. So if we're going left or right, that's changing our x values. And so if we're going to the left, right, if we're on the coordinate plane, we're moving to the left, we think we're going to subtract 5, but remember, we're not. It's the opposite. We're actually adding 5. And make sure, like the problem, like it needs to be written the way that I wrote it. But if you write it like that, that's not right. Or plus 5, that's not right. This is a vertical transformation, not a horizontal transformation. So x plus 5, and then down 7. So now on the same level of the base, the base of 2, we're going to go down 7, and that's changing y values. And the y values always are transformed exactly the way we think they would be. So if we're subtracting 7, it's being shifted down 7 units. And so that is it. I want you guys to do example 1 and example 4. And from here, you can start working on your homework. And I will take homework questions when I see you guys again. And then that is it. So I will see you later this week.